I like to keep the shapes together, so we're going a little bit out of order. So we're going to talk about surface area. Of pyramids and cones. So let's talk about our vocabulary first. Let me grab a picture. So the quick way to draw a pyramid is you draw, so say we have a square pyramid, draw kind of a trapezoid, not a trapezoid, a parallelogram, and then a dot, and just connect that dot to all the vertices. And you have a nice pyramid. But I'm going to grab a picture here. And we'll talk about our pieces, our parts of our pyramid. All right. All right, so a pyramid is a polyhedron. And remember, a polyhedron just means it's made up of polygons. It's a polyhedron with a base. The base of a pyramid is a polygon. So we can have a square pyramid, we can have a triangular pyramid, we can have a trapezoidal pyramid. Any polygon can be the base of a pyramid. So my base is this square here. We have lateral faces. And the lateral faces of a pyramid are all triangles. So this would be a lateral face. Lateral just means side. We have a vertex. The vertex is where all the lateral faces come together. Just like we think. So that's our vertex. We have base edges. So this would be a base edge. That's where the base meets the lateral face. We have lateral edges. Lateral edges are where the lateral faces come together. So this would be a lateral edge. We have an altitude or a height. The altitude or the height goes from the vertex perpendicular to the base. So I'll draw that in here. Here's my altitude or my height. And that's a 90-degree angle. And another important piece is a slant height. And the slant height goes from the vertex perpendicular to a base edge. So that would be, I'll draw that in green, that would be my slant height. And we go perpendicular to the base edge. And the slant height is going to be important for finding the surface area. And we name a pyramid by the shape of the base. So this would be a square pyramid. We can have a triangular pyramid. We can have a trapezoidal pyramid, just like a prism. Any polygon can be the base. All right, we're good so far with our vocabulary. All right, a couple more pieces here. A regular pyramid. Regular pyramid just means the base is a regular polygon. So our base would be a square, an equilateral triangle, and a regular hexagon, regular pentagon. So all the sides are the same. And the lateral area, when we talk about the lateral area, is the area of the sides. So what I want to do is, just like we did for our prisms, I want to draw a net for a pyramid, and we're going to look at how the net gives us the formula for our surface area. So our net for a pyramid is going to look something, I'll draw a square pyramid here. So here is my base, and we get a triangle on each side. So our lateral faces are all triangles, and my nets don't always turn out perfect, but just pretty close. So my net looks like this. If I folded that up, all the triangles meet at the vertex. So this is my base, and I'm going to say the base is a square. I'm going to call the sides S for sides. So all my base edges are length S. And the slant height of the pyramid is the height of one of those triangles. So there's my slant height. And we'll call the slant height L, a script L. So this is how we're going to find the area, the surface area of a pyramid. We cut it open and we get a shape that looks like this. And we're going to add up all the areas of these things. Well, the area of one triangle is the base, S, times the height, L, divided by 2. The lateral area, so the area of all the triangles, well, we have 4 of those. 4 times S times L divided by 2. Well, what do I get when I add up 4 of these sides? 4S, but for this square that makes up the base, if I add up those 4 sides, what is that? That's the perimeter of the base, just like we had yesterday with our prism. So we're adding up 4 of those. 4 times S is the perimeter of the base. So we get P times L divided by 2. So that gives me the lateral area. The total area is, I'm going to switch the order of these two, L times P divided by 2. That's the area of all those triangles plus the area of the base. So to find our area, we're looking at the lateral area plus the base area. And in this case, the base area is just the area of the square. So we're adding up the lateral. Our formula comes from adding up the area of the triangles. We get the perimeter times the slant height divided by 2. And we add that to the base area. So that's where our formula comes from. You can always find your surface area by making a net. But the formula comes from this. So let's write out our formula, and then we'll talk about what all the parts mean, and then we'll look at some problems. So the surface area. Surface area of a regular pyramid. So we'll use SA again for our surface area. Is LP divided by 2 plus B, units squared. L is the slant height. P is the perimeter of the base. And B is the area of the base. And again, this is the lateral area plus the base area. That's our formula. The lateral area plus the base area. And just like with prisms, the perimeter of the base depends on the shape of the base. The area of the base depends on the shape of the base. All right, questions? All right, let's look at a couple of examples. So we're going to work with square pyramids for now. Surface area equals, and I'm going to say this is a square pyramid. So when we say square pyramid, that means the base is a square. So we know all the sides are the same. And I'm going to label some stuff here, and then we'll do our calculations. So that is 12 centimeters. And this is 8 centimeters. All right, so we need the slant height. What is the slant height here? 12. They give us a slant height. That's nice. Slant height is 12. We need the perimeter of the base. So what's the perimeter of the base? How do we find it? 8 times 4. All the sides are the same, so we get 32. The area of the base. The base is a square, so how do we find the area of that square? 8 times 8. Length times width, base times height. So it's 64. So our surface area is the slant height times the perimeter of the base divided by 2 plus 64. Now be careful. We only divide this first part by 2, not the whole thing. So we do this calculation separately and then add 64. So 12 times 32 divided by 2 is 192 plus 64, and we get 256, and my units would be square centimeters. So that's my surface area. All right, questions? Okay. Let's look at another example where we have to be a little more careful. So a square pyramid again. A square pyramid. And for this one, I'll label some parts here. I'm going to say this is 8 inches. That's 8 inches. This side is 9 inches. And we want the surface area. All right, we need the slant height. Do we have the slant height here? No. We have the height. Let's draw in the slant height. The slant height goes there and makes a 90-degree angle with the base edge. So there's L. Well, here's what we do in this situation. I can connect those two, and then I'm going to draw that triangle. I'm going to draw that triangle on looking at it as a side view. So there's that. There's that. And here's the dotted line that I drew. That's a 90-degree angle because the height is perpendicular to the base. That's 8. There's our slant height. Well, how far is it from here to here? If this is a square. That's half the edge of the square. That's 4.5. We always get a right triangle inside a pyramid that we can use to help us solve our problem. So what are we going to do here to figure out our slant height? Pythagorean Theorem. So I'm going to say L squared. This is A. This is B, and this is C. So let me erase that. I'll write it in the order that we're familiar with, and then I'll change it around. 8 squared, A squared plus 4.5 squared equals L squared. A squared plus B squared equals C squared. Well, we get 64 plus 20.25 equals L squared. So L squared is 84.25. To get L, we're going to take the square root of both sides. And my slant height is 9.18. Now let's figure out the rest of our stuff. The perimeter of the base. How do we figure that out? 9 times 4. So we get 36. The area of the base. 9 times 9. It's a square. 81. So I can calculate my surface area. The slant height, 9.18, times the perimeter of the base, 36. Divide that part by 2. And then separately we add 81. This is 165.2 plus 81. When I calculate this out, I get that. And I get 246.2 square inches. So that right triangle inside a pyramid shows up often in these kinds of problems. All right, questions? Okay, let's look at cones. So the easy way to draw a cone is if you draw a little oval and then a dot above, and then just connect the dot with the side of the oval, and there you have a nice cone. I'm going to grab a picture of a cone, and we'll talk about our pieces of a cone. There we go. So there's my cone. So I'm going to say a cone is a surface or a solid with, why is it not a polyhedron? No, it's not made up of polygons. So it's a solid with a base. What's the base of a cone? A circle. So here's my base. And this is the radius of the base. It has a lateral surface. And we'll talk about what that lateral surface is in just a second. But all the rest of this is the lateral surface of the cone. It has an altitude or a height. And the altitude or height of a cone is exactly like the altitude or height of a pyramid from the vertex perpendicular to the base. So that would be my height. We also have a slant height. And the slant height on a cone is actually a little easier than the slant height on a pyramid because we just go from the vertex down the side of the cone. So that's my slant height. And we also have a vertex. So there's my parts of a cone. Now what I want to do, just like we did for the pyramid, I'll talk about the net for a cone. Net for a cone is a little more interesting because it's all curved. So I'm going to write on the next page net, and before we draw it, I'm going to show you a little demonstration. So what I have here is I cut a circle out of a piece of paper, and then I cut a wedge out of the circle, so along to the middle of the circle. And if I fold this up so these two edges meet, I get a cone. So the slant height of the cone is the radius of this circle that makes up the lateral surface. So when I put those together, that's the slant height of the cone. Put those together, that gives me the slant height of the cone. And then the circumference of the base is a portion of the circumference of the circle that makes up that lateral surface. So a cone is actually made up of a part of one circle and another circle, because we have a circle that makes up the base of the cone. So our surface area formula comes from finding the area of this piece of a circle. So it's related to the area of a sector that we talked about last chapter. We talked about the area of a sector of a circle. And it also has to do with the area of the circle that makes up the base of the cone. So that's where our formula is going to come from. So our net is going to look like this piece with the circle that makes up the base attached to it. And our formula is going to come from finding the areas of those two pieces. So here's what our net is going to look like. Let me grab, here's a circle that I cut out the wedge from. So I cut out a piece of that circle, like so. So my cone, the lateral surface of my cone is made up of this portion of that circle. And this length is the slant height. So the slant height is the radius of that circle that I used to make the lateral surface. So my slant height is L. The lateral area, area of the side, when I find the area of that sector, I get pi r L. And r there, let me get my base on here. R is the radius of the circle that makes up the base. So when I fold this up so those two sides meet, this is going to fit on the base of that cone. And the base area is the area of the circle, pi r squared. So my surface area of a right cone, and right just means that the vertex is right above the center of the circle that makes up the base. Surface area of a right cone. We add up the lateral area, pi r L, plus the area of the base, pi r squared. And we get square units. This is the lateral area plus the base area. Just like the formula for a pyramid. So we can think of a cone as a curvy pyramid. And the cones are actually simpler, even though they're curved. They're simpler because there's less to them than pyramids that are made up of a bunch of pieces. Cones are only made up of two pieces. All right, questions there? Okay, I just want to look at one more example using a cone, and then we'll be set for today. So here's my cone. And I'm going to say that the radius of the cone is 5 centimeters. And this portion, that is 12 centimeters. And that is perpendicular. And we want to find the surface area in terms of pi. All right, so we know we need the slant height. Do we have the slant height here? No. There's the slant height. How are we going to find the slant height? Don't we have a nice right triangle there? We can use the Pythagorean Theorem again. There's a right triangle in cones, just like there's a right triangle in pyramids, that we can use to help us solve problems. So this could be A. The height could be A. The radius is B. This could be C. So I'm going to say 12 squared plus 5 squared equals L squared. So L squared equals 144 plus 25. So L squared is 169. We need to take the square root to get our slant height. L equals square root of 169 is 13. So now we have everything we need. Our surface area is pi times the radius times the slant height. plus pi times the radius squared. And we want our answer in terms of pi, so I'm going to leave the pi here. 5 times 13 is 65. Pi times 5 squared is pi times 25. And I can add these just like I add 65x plus 25x. 65 plus 25 is 90. And I have the pi still out there. So I get 90 pi square centimeters. So that would be my surface area in terms of pi. So you have a right triangle inside pyramids, a right triangle inside cones that you can use to help you solve problems. All right, our homework is on page 712. Nine through 36 even. I would suggest, I'm not going to collect this, but in your book, since we don't have a quiz in this chapter, there's a mid-chapter quiz. It's on page, I think it's on 417, is that what I decided? 416. I would suggest that at some point between now and when we have our test, you would look at those problems in the mid-chapter quiz and work through some of them so you can figure out how to solve them. Because those are the kinds of questions you're going to get on your test. So again, I'm not collecting that, but I would suggest that you work through those. Any questions on the work from page 722? Yes. Number 34. All right, let's take a look. All right, so number 34 says the volume of a cylinder. Yeah. 18. So number 34 says the volume of a cylinder is 135 pi. And it tells us that the height is 15 centimeters. We want to figure out the radius of the cylinder. Well, we know the volume is pi r squared h, and h is 15. So really what I'm doing is solving for r here. I'm going to divide both sides by pi. Those go away. And I get 135 equals 15 r squared. Divide by 15. R squared equals 135 divided by 15. Is 9. Take the square roots. R equals 3. All right, number 18. They give us a picture. This is like the example we did in class yesterday. They give us a picture that looks like this. And they tell us this is 12. This is 4. And this whole height is 17, and they want the volume. Well, we know that this is 12, so the radius of this thing is 6. 17 minus 6 is 11, so that side is 11. So we find the volume of this prism, length times width times height, plus the volume of half of that cylinder. All right, let me pass your folders back. Homework can go in your folders. Be aware, everyone, that these problems all require some kind of work.
Really?
Yes, you can't do the first 5 problems and then do them over again.
You want to check my homework?
I'm not doing it anymore.
I never did it, Debbie.
So if you're turning in a list of answers, you are not getting full credit for your homework. So be aware of that.